Okay. So the idea today is we're going to talk about angles a little bit more and apply that to polygons, which some of you guys probably already know what a polygon is, which is great. If you don't, no big deal. So first thing you're going to do, because we're going to do a construction, shocker, right, is I want you to make an angle on your page. So do it however you want. I've got graph paper, so I'm going to make my bottom ray. Uh-oh. Pen's dying. My bottom ray flat, perfectly horizontal. Remember, an angle is made up of two rays that intersect at an endpoint. And try to make sure those, oh yeah, if you want to grab protractors for a straight edge, that might be a good idea as well. Sorry, I did not grab any for you. Go, 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 go. So any angle you want, just make sure your rays are straight. What you're going to do now is, after you get that, take out your compass, right? And what you're going to do is you're going to mark off a distance from that endpoint. Come on. Like I'm doing here. And you're going to intersect each ray. So there's one, right? And there's two. So now I have two intersections with you know, each ray. There's one there, one there. So make sure you've got something that looks like that happening. What we're going to do is we're going to bisect this angle, which again means to cut it perfectly in half. And you can do this with any angle. It doesn't matter what angle it is. It works the exact same way. No measurements required. But we're going to be able to cut it perfectly in half. So let's call this angle something. So how about we call it angle ABC. Now, if we're going to call it angle ABC, we have to label the dots ABC. And how are we going to label those? Okay. So which one has to be the vertex? B, right? So that has to be B. We'll call this one A, the one on top, and C, the one on bottom. If you goofed up, or if you switched A and C, no big deal, right? Same dumb thing. It's just B has to be the vertex because it is in the middle for the name. All right, so now what we're going to do is bisect this baby, right? We didn't measure it. We could if we wanted to and figure out that mine's about 25 degrees exactly. What a god. Look at this. Boom. That's 25, baby. Only thing funnier than 24. Anything about that one? So now what we're going to do is take our compass, and we're going to go to A and C, and we're going to draw an arc that goes through what we think will be the point of bisection. So here's what I'm going to do, right? Here's my arc. And see how I know if I have a bisector here, it's going to go through that arc. And without changing my compass settings, I'm going to do the same thing at C. So we're going to get two arcs that intersect at a certain point. Kind of hard to see, isn't it? Let me brighten this up a little bit. Yeah, not much better. So again, what I did is I put my point of the compass on A, and I drew an arc. And then I went to C and drew an arc that's the same compass setting, right? So if we're thinking in terms of circles, our radius for the circle that we're drawing is the same when we go for A and C. So A and C are centers of circles. And we only drew the part of the circle that we need. Where those circles intersect, where those arcs intersect, put a point. Let's call that point D. And I think you know what's going to happen next, right? We're going to take out our straight edge. Oh, yes, Lainey? Gotcha. Well, that's also a terrible protractor because that's actually a compass, but I confuse them all the time. You think the compass would be the round one, right? You know what I mean? You know what I mean? You know what I mean? We've got some options for you. I'm going to give you all of them. You can try out each one individually, and you can choose your favorite color, and it will make you so happy.
How do you lock it on a certain
What you can do for some of them is you can loosen up the nut like this, and then open it up, and then tighten it back up. Okay. So once you have your setting, you can tighten it up. Okay, so next thing we're going to do after we have that point, and again, we got that point by putting our compass on A, drawing an arc, keeping the setting, putting it on C, drawing an arc, right? The intersection of those two arcs is going to be point D. Then you can take out your straight edge, or what have you, And if you connect B to D, we now have a third ray that is bisecting angle ABC. So when we write this, right, because not always are we going to be able to draw this stuff, not always do we want to draw it, we want to be able to write it. What we would say is that ray BD bisects angle, because that's the angle symbol, right, angle ABC. Now, if this is true, if ray BD is bisecting angle ABC, what does that tell us? What's up? Cut it in half, exactly. So what do we know about this diagram? What else do we know? We know this, right? That angle is the same as that angle. Now, how do we write that, right? I've shown you visually how we do it, right? We put little tick marks. How would we write that those angles are congruent? Angle what? ABD. Yep, equal with a tilde. That's the congruent sign. Remember, we're talking about the figures here. We're not saying that their number, like they're 27 degrees each or something, right, is equal. We're saying that the figures are congruent. So what is ABD congruent to? What other figure? Angle DBC. So what I'm going to do, because if I write DBC like you said, it's not quite as perfect as it could be, and this is just me being picky, I guess. See how D is in the third position here, and it's in the first position there? Well, there's a way we can rearrange D and C to where almost everything lines up, where B is in the middle, D is on the end, right? So I'm going to rewrite that as angle CBD, which is also quite satisfying for other reasons. Nice. So, therefore, those two angles are congruent. Now, did we measure this angle at all? Did we measure it to be, I mean, I did. I measured it to be 25, which means these two angles should be 12 and a half. But did you measure yours at all? No, right? Most of you didn't even really have a protractor. You don't need to measure it to cut it in half. Same thing when we did the segment thing, right? Where we drew our own segment like this. Here and here. Enough, Jenna. Was it actually Jenna? It was always Jenna. And then we extended our compass more than halfway. These are amazing. Okay, like they're super dangerous, but like this is the compass. Like everyone should have one of these in their car, ready to go at all times. All right, and if we go more than halfway, we get something like this, right? And we bisect the angle, right, where they intersect. Look at that, perfect bisection. And of course it is, right? You can even count the squares. And then, boom, cut it in half, right? Not only that, but it hits it at 90 degrees. What do we call something like this? So if I have A and B here, and I have C and D here, segment CD, does anybody remember what we call segment CD if it cuts it in half and hits it at 90 degrees? It's got two words that really are the big deal about the name. Cuts it in half. What word do we use for that? Yep, so CD is a something bisector. It's not just a bisector. Anything can cut anything in half, right? If I do this, that cuts AB in half as well, right? It hits it right at the halfway point, the midpoint. But it doesn't hit it at 90 degrees. Hits it about 45, almost exactly. What about CD? Yeah. Say it again. Not complementary, although I see where you're going there, right? Complementary is 90 degrees, right? You're thinking from yesterday's notes. This is from a while ago. It's like one of the first constructions we did. What does it mean to hit something at 90 degrees? It's got a special word. Right angle, that's true. But we don't call it a right angle bisector. That'd be convenient, wouldn't it? Starts with a P. You want to say parallel, but it's not. Perpendicular, right? I don't know if you noticed, but this entire time I've been writing in a perp pen. Is this your card? Yes, it is, since the beginning of time. That's right. Working on like 12 different levels here. You're playing like checkers, I'm playing like 4-dimensional chess. Okay. 420, 69 IQ. All right. Questions, comments, concerns on this other than from my mental stability? That's how you bisect an angle. Could you do it on your own? I'm going to give you a couple minutes so we can have a song of the day. I want you to bisect the angle on your own. Do it now. If you need any help, ask. Also, while you're at it, could you bisect a segment for me? Construct a perpendicular bisector?
No.
Try it. Okay? Again, how did I do it? Real quick. Made an angle, any angle. You can make a straight angle if you want, okay? Make a reflex angle. I don't care what you do, okay? You mark off a point A and C on it. Remember, they have to be equidistant from B. So I choose a compass setting. I mark off A, I mark off C, right? They're all in the same arc. Are you with me? I mark off A, I mark off C. And after I get them, I keep my compass setting, and I see where they would intersect. That's a perpendicular bisector. Here, or I'm sorry, that's a angle bisector. This guy right here, to do this, I draw a line segment. I go more than halfway between A and B. And where those arcs intersect creates 2 points. And that gets me my perpendicular bisector. Try it on your own. The song of the day is by Thundercat, who is probably the world's best bass player, like currently alive. I'm not sure about ever, but it's close. This guy is like a 12-string bass. He's this giant guy with dreadlocks that are like rainbow colored. And he has this huge bass. And again, his name is Thundercat. He's real good. This is him with Kenny Loggins, who is like a white soul singer from like the 80s. Did the Footloose soundtrack from his album Drunk in 2017, which has an amazing album art to it. The song is Show You the Way. Also, Michael McDonald's on this, who is like another lesser known, I guess not lesser known, but not as well known as Kenny Loggins. Just listen to this, it's like everything's gonna be alright. Confused about how to construct an angle bisector, watch here so I can help you all at once. Protractor. You love this song, I know. Alright, here's my angle. Here it is. Okay, there it is, my angle. Now what I'm going to do is I'm going to find 2 points on either ray that are equidistant from that endpoint. So I pick a compass setting, do that, do that. You with me? So I've got a point here, and I've got a point there. Then what I do is I pick those points, and I draw another arc that's going to be in the middle of the angle, and I keep my setting, and where those arcs intersect, that is going to be a point that when you connect that, cuts the angle in half. We call that thing that cuts the angle in half an angle bisector. Ta-da! So again, step 1, find a point on each ray. You can do that in one swift motion like this. 2 points, right? And then you pick a compass setting, draw little arcs, and where they intersect gets you another ray, and that ray is an angle bisector. Then for funsies, bisecting a segment. Here's the segment. I open up my compass to make sure it's more than halfway across between those 2 points. See how that's more than halfway? Smell what I'm doing. And so now that I have that setting, I draw an arc here, and I keep that setting. I draw another arc, and where they intersect produces 2 points. When I connect those points, if I did my arcs well, I have a perpendicular bisector. Not only that, but the original segment, AB, cuts my new segment in half as well. Hooray, no measuring required. Visual proof that we can always cut a segment in half and say, hey, that's the midpoint, so says I, right? Same thing with cutting an angle in half. That's the angle bisector. These 2 angles are congruent, so says I. A visual proof, if you will. That's the deal. How you feel? Better? Or still awful? Is the hardest part of doing this following the directions or dealing with the compass? What's the worst part of this, Jenna? What's the worst part of this? Is it the compass or is it following the directions?
Both.
Both. Gotcha. Would everybody agree both?
I would say
Compass? Yeah. Like, I feel like the directions wouldn't be so hard if you weren't fiddling with this the entire time and trying to, like, make this piece of garbage work. I wish everybody had one of these. The only downside is that, like, that is very dangerous, and they don't like us having these, I would assume. Also, these are probably more expensive because they actually work. Like, this is, look, just look at that. Oh, no, you can't do it? Okay, well, look at this. Like, that is glorious. Like, that ain't going nowhere, right? Isn't that amazing? Right? And what's great about this is you're not, like, tightening it to the point where it's, like, going to break either. Because when you tighten it too much, eventually, like, this thing gets loose, right? But, like, this mechanism, that ain't going to happen. First of all, it's not plastic. It's metal, so it's going to be a lot harder to bend and, you know, pop out of alignment. Just a work of beauty. Everyone should have one of these. And I'm sorry you don't. But that's just the way it be sometimes, you know? All right. Let's put that away. So today is a moron day, and you're thinking, wait a minute, a moron? I'm not a moron, and you're right, you're not. We're doing more on the last lesson. And now, this is a particularly weird moron day because really we're not doing more on the last lesson. We're just doing more on what you learned in like 5th grade. So it's kind of like a review day, but not really. It's kind of in between. Okay? So what we're going to do after we go through this homework and grade it in class, right, which is what we're going to do now, is we're going to take a look at this worksheet that I've got for you. We're going to talk about polygons and perimeter. I think you guys all know what perimeter is. We talked about it yesterday with circles. It's called circumference for circles for some reason. And then polygons, I think you guys probably have a general idea of what that is. It ain't no thing. We're going to be doing some more distance formula today, which hopefully is no thing for you because it's going to be on the test Friday. All right, kiddos. So, our worksheet from yesterday, which I just got rid of my extra copy. We're going to do it live. All right, class. Feeling purple today. Draw angle ABC. Boom, boom. A is the vertex, B is this, and C is that, right? Questions, comments, concern? Why? Why not?
Because B is in the middle.
Oh, that's right. Who did what I did? Hopefully you don't do it on the quiz. Ta-da. B has to be in the middle. A and C can be interchangeable, right? All right, give me 4 names for number 2. 1 name, Noah. Yeah, angle 1. Always have the angle symbol. What is the difference between the angle symbol and a less than symbol?
One's flat.
Yep, one sits horizontally, like flat on a line, where the other is sitting at an angle, and it's not the one that's the angle that sits at an angle. Right?
Yeah.
That wasn't a question. It wasn't a thing you had to answer. I was just asking.
No, I just didn't understand what you were saying.
Oh, I will slow down.
I
So,
understand now.
oh, wonderful.
Just- pretty much.
Sublime, if you will.
Yes.
All right, number 2. Give me another one. Yes.
YXZ.
So angle Y XZ. That is correct. Jenna, give me another one.
Angle ZXY.
Angle Z X Y. And last but not least, probably my least favorite way to name an angle. Schrader.
YXZ.
Already got it? YXZ, ZXY. This is the silly one. Yeah, go ahead, Bo. Help her out.
X.
Angle X, that's it. It's not just naming it by the vertex. The most important point. Which I don't like, because imagine if we had other rays sticking off of here. Right, which one's angle X now? Well, this one, this one, this one, and this one, and this one, and that one are all angle X. You see that it's ambiguous? And if you don't know what ambiguous means, that's fine, because ambiguous means unsure, right? So it's unsure. So typically we name it by this stuff, because then there can be no mistake. If we call this point A and this point B, well, if I say YXZ, well, there can only be one, right? Just like me. You know I used to be a twin, right? Can you imagine? That's right. There can only be one. All right. Next one. True story. Acute. If angle A is an acute angle, it has to be between what and what? Yeah, go ahead. 0 and 90 degrees. Inclusive or non-inclusive?
What?
Inclusive means it includes 0 and 90.
No.
Non-inclusive, right? Why can't angle A, if it's acute, be 90 degrees?
Because it's right.
Because it's a right angle. Thanks for answering my next question. So a right angle means that if angle A is a right angle, then angle A is equal to 90 degrees. Wonderful. Fantastic. Great. All right, what's the next angle going up in order? It's between what and what? Obtuse. And it's between
90 and 180.
90 degrees, 180 degrees, and we write that like this, between. If you think in terms of between, right, you always use less than signs. You don't have to worry about which way the sign goes. Start from low to high, right? Makes sense to me. Another way to read this is that 90 is to the left, because it's pointing to the left of angle A, and angle A is to the left of 180, right? Has to be between them. Next one, what do we call it?
Straight.
Straight angle. So a straight angle is exactly what? So if measure angle A is a straight angle, then the measure of angle A is exactly 180. Next, it's the hyperextension one, right? Reflex. Thank you, Courtney. So reflex angle. If angle A is a reflex angle, then the measure of angle A is between what two numbers? 180 and 360. Last one that's not in your notes, but we did talk about. What's the last one? Revolution. And a revolution is exactly how many degrees? 360, no scope. I found the Snoop Dogg video, by the way. It's hard to find. You'd think like 360 no scope 420 MLG would like get it, but there's like so many of those videos on YouTube. You know, I'm debating it.
We should.
I found the point. It's at 24 seconds that they stop saying bad words, and so it might be possible. All right, turn the page. All right, angle CAF. So let's do some colors. All right, so CAF is going to be in this like weird color right here. There's C, there's A, there's F. So we're talking about this angle right here. So what angles do we need to add up? What angle measures do we need to add up to get the total? 15, 30, and 45. And we found out yesterday that even though it adds up to 90, it doesn't look like it's 90. It still is 90, right? Isn't that annoying? Yeah. All right, next angle, BAF. Well, there's B, there's A, there's F. So we're talking about this angle right here. So we got to add all those up plus the 30, right? Well, we already added all those up. So a quick way would be not to add them all up again. It would just be say that's 90 plus 30 is 120. Wonderful. Let's pick another odd color. I'm not sure what this is. What do we call this? Like periwinkle? Cornflower? Cornflower?
A light blue.
Light blue.
Yeah.
There you go, Bo. All right, EAB. EAB. So we're talking this angle right here. Okay, so EAB is going to be 90 minus 45, right? That's what this is. 90 minus 45, so that's 45 here. Plus 30. What's 45 plus 30? 75 degrees. All right, let's pick another strange color.
There's that one.
Which one?
Right
Well,
there.
if you told me the color, it would be this one right here. Okay, well, it's kind of another pink. What is this, like cotton candy?
Yeah.
Sure.
Yeah, cotton candy. DAE. DAE. Well, that's just this guy right here. What's that? 30. Oh, that's convenient. All right, last little bit. If you extend ray AF backwards to form a straight line GAF, so let's do that. Here's AF. If we extend it backwards, we're talking about this. Laney, are you a big Snoop Dogg fan? I knew you would be.
So is that supposed to say BAF because there is no G?
Yeah, so we need to pop a G on here.
Sounds good to me.
I knew it would. GAF. What would be the measure of GAB? So GAB is what we're looking at. Let's use perps. GAB. So here's G. There's A. There's B. What is this angle going to be? What do you think?
180 minus the
Why is it 180 minus, you said DAF? Or BAF, right? Why is it 180 minus the measure of angle BAF?
180 is the straight line, and then EAF is the whole thing.
All right, nerds, check it out. We have a straight angle here. When you extend a ray backwards, you get a straight angle. And straight angles are exactly how many degrees?
180.
180, but we don't want the whole thing. We don't want that. We just want this little bit. So what do? We subtract all this other stuff. Well, how much is all of this other stuff? Let's use rad to represent all the other stuff. Well, it's 90 plus 30, which is 120, also known as our angle here, right? So we have 180 minus 120 is what?
60.
60 degrees. Oh, yeah. I feel like I missed an opportunity to make that more interesting. But anyway, that's the deal. Here's what we're going to do. 1 point for everything that's on here. So I want 1 point for number 1. I want 4 points for number 2. I want 1, 2, 3, 4, 5, 6 points for number 3, which isn't really number 3 because I didn't label it. Sorry.
Did you want to do complementary and supplementary?
Oh, did I miss those? Oh, my bad. Complementary and supplementary. Somebody tell me what complementary means. So angle A plus angle B equals what? 90. Right? If A and B are complementary, then their angle measures equal 90. And then sup is what? If A and B are supplementary, then what must they add up to? 180. So make that 8 points. The Ocho. ESPN 8. So we have 1, 2, 3, 4, 5, plus 8 is 13 on the front. We got 1, 2, 3, 4 here. One more here. So 5 on the back. So 13 and 5 makes 18 total. How you feel? Deece, if you love your grade, turn it in. If you don't love your grade, fix it. It's literally on YouTube now. Like, you don't even have to screenshot this while I put all the answers down. I'm so nice. Are you guys catching on that, like, homework is literally just for your own benefit and there's no penalty to trying? Yes? Noah? Keep him on the desk for the next class. What's the answer to what? 7? Wait, what? The last one on the back page? This one? 60 degrees. Oh man, what did you say it was?
75, because I just guessed. I guessed by not guessing. That makes sense.
Gotcha, I understand. You were just like, I don't know. It could be that. Yeah, you gotta be clever. That's a straight angle, my dudes.
I thought class was
Nope. All right. Do you see it now, Mr. Krabs? All right. Okay, so now we're gonna take a look at this. Snoop? We haven't earned Snoop yet. Snoop does not love you just because you want him to love you. You have to earn his love.
Who is, have you earned it?
Who is Snoop Dogg? I haven't, but I try more and more every day to be more like him. All right. What it is, cuz, what it is. All right, so we're gonna write the name of each polygon. Oh yeah, you don't have one of these. Let's pass those out. Man, it's a mess this morning, just a mess. There you go. There you go. There you go. Don't pass them back. It's all one thing. What are you doing?
What?
Jerica. Oh man, it's so many pages. Oh no. How many questions are on it? 5. Okay. 5 questions. And it's got questions like, is it concave or convex? Come on. This ain't hard. We're going to talk about concave, convex, though. So what we're going to do is, because this is a moron, we don't really have any notes. What we're going to do is we're just going to do number 1 together, and that's going to help you with the rest of the stuff, okay? So it says, write the name of each polygon and tell whether the polygon is convex or concave. So here's the deal, kiddos, okay? What is a polygon? Well, a polygon is any figure that has sides, so it doesn't include circles, and those sides all intersect at endpoints. So, like, that's a polygon. It has sides, and they all intersect at the endpoints. This would not be a polygon because the sides don't all intersect at endpoints, right? That intersects somewhere between the 2 endpoints here and here. So that's not a polygon. That's not a polygon. Circles are not polygons because they don't have sides, even though that one kind of does almost, right? But it's okay. He's not perfect. You don't have to be perfect. Okay? He identifies as a circle. That's a polygon. This would not be a polygon. Are we blowing our minds here? Sweet deal. All right. So tell whether it's convex or concave. So here's the thing. So if you were to extend out these sides, okay, kind of like we just extended that ray from before, remember AF, and it was. If we were to extend out all of these sides, see how they just keep going, and they keep going, and they keep going, and they don't stop coming, and they don't stop coming, and they don't stop coming, right? Smash Mouth, anybody? Shrek 5, are we excited?
Yes.
Okay, so notice how if I extend those out, none of those lines go into the interior of the polygon. We talked about interior yesterday. Remember, it's our inside voices, interior voices. It's on the inside, interior design, right? Okay, none of those lines go into the interior, which means this is convex. Okay, the way I think about it is concave's like a cave, and caves go in. So if I have a mountain, right, there's my mountain. A cave would go into it, right? That's concave. Whereas convex is something that sits like that. It kind of pushes outward. So convex is kind of like a contact, right? It sits on your eye like this. If your contact went into your eye like that, that would be painful, right? You don't want a contact shaped like that. That would not be good. That's how we get corneal damage, like I have, because I didn't know how to blink. Something I'm working on. Other than being more like Snoop Dogg, blinking is the other thing I aspire to. Mark congruent segments. So, the segments, which ones are congruent, if any? And how do we know if they're congruent? Well, we have to measure them, right? So pull out your ruler. No! We're going to use distance formula, right? So let's do that. You know what's easier than distance formula? Pythagorean theorem. I can draw a triangle right here, and I can figure out how long that side is, can't I? So if that's 4 and that's 3, that's a 3, 4, 5 right triangle, isn't it? So the length of BC is 5. Yay! Hooray for Pythagorean theorem. 3, 4, 5, right? So the length must be 5. 3 squared is 9, 4 squared is 16. Add them together, we get 25, root it, 5. If you look at ED, 3 and 4, right? That's a 3, 4, 5 right triangle, which means what is the hypotenuse? What's that hypotenuse going to be? 5, right? 3 squared is 9, 4 squared is 16. Add them together, we get 25. We root it, we get 5, right? So these two sides are congruent. So I'm going to put a little tick mark there and there. Now, what about A to E? Yeah, we could draw a triangle kind of like I did, but that was on accident. How would I measure A to E really quickly? Any ideas?
4.
What?
4.
How do you know it's 4?
Count the
You
box.
count the boxes, it's horizontal, right? There is no vertical change, so it's just 1, 2, 3, 4 to the right. That's 4. Ain't no thing. Now we got to go get A, B, and C, D. So I'm going to draw triangles again. I'm going to see if I can figure it out with Pythag. So check it out. That's 1, 2, 3, 4, 5, 6, 7, 8 down here. And that's 1, 2, 3, 4, 5, 6 here. So we have 8 and 6. That's not a nice right triangle. So 8 squared plus 6 squared, all rooted, should get us the length of CD, right? Well, that's going to be 64 plus 36. Look, maybe it is nice. What's 64 and 36? 100. And what's the root of 100? 10. See, I didn't think that was a nice right triangle because, you know, I know 3, 4, 5. I know 12, 5, 13. Those are nice Pythagorean triples. How do we know that 6, 8, and 10 are Pythagorean triple? How could we have known that ahead of time? What other Pythagorean triples are we aware of? Right? 3, 4, 5, right? What happens when you double 3, 4, and 5? 6, 8, and 10. Right? It's the same triangle, just twice as big. Of course it's still a right triangle. If I times it by 3, we get 9, 12, and 15. That's another right triangle. So CD is 10. Which means if this is 10, if this is 10 too, then we have congruent sides. Let's check it. 1, 2, 3, 4 here. Nope, not going to happen. 1, 2, 3, 4, 5, 6 here. Ooh, it's a 4, 6. What's that? Well, 4 here, 6 there. Let's do that. 4 squared plus 6 squared, all rooted. 4 squared is a fun game to play outside, but it is also 16. Enough, Chloe. And that's 36. And that's going to give us the length of AB. Well, it's 16 and 36. Better question. What's 36 and 10?
46.
What's 46 and 6? 52. So root 52, which sounds like a fun place to drive. So that's root 52, which is not 10, right? Because root 100 is 10. So we have two congruent sides, and the rest are not. Now it says write the perimeter. First of all, what kind of shape is this? How many sides do we have here? 5. We call that a pentagon. So you might want to write this down. Starting from small to big, we have triangle. Then we have quadrilateral. Quad meaning 4. Lateral meaning line, right? Or side. So quadrilateral. So that's the 3, that's the 4. The 5 we call pentagon, like Satan. 6, what do we call a 6-sided? What? Hexagon. Anyone know 7? The guess is septagon, right? That's what I would call it. Either that or a 7-gon. That's the cheater way, right? You just say the number. What about 8? Octagon, everybody's favorite, the stop sign, right? And then after that, we have a couple that are kind of important. We have a decagon. What do you think that is? 10, right? Like December, because it's the 10th month of the year. And then we have a dodecagon. Dodec. So dec meaning 10, do meaning 2, like dose, right? So that's 12. Dodec. If we want any type of gon, what we do is we call it an n-gon, n meaning any number. So if I wanted a 72-sided polygon, I'd say a 72-agon. Right? I'd prefer you to use these names: triangle, quadrilateral, pentagon, hexagon, and octagon. These 2 are bonus. Don't say septagon. You can just call it a 7-gon. Same thing with 9, 9-gon. 9-gon! All right. So this is a pentagon because it has 5 sides. Back to the perimeter. We have 5 sides, so we need to add up 5 sides, right? That's the perimeter, the outside area, the outside length, I should say. So we have 5 here, right, for BC. We've got 10 here for CD. We've got 5 here for ED. We've got 4 for AE, and then we have root 52. And you're thinking, okay, now what? Well, do what you can, right? Don't get out a calculator. What's 5 and 5? What's 10 and 10? What's 20 and 4? So P is 24 plus whatever root 52 is. Done. That's the perimeter. It's okay. Sometimes you have to represent things in 2 terms. Because otherwise, what do? You plug that in your calculator, you get a decimal that goes on forever and never repeats because it's an irrational number, and you round at some point. And the question is, why? If it's okay to round, then we don't have to be precise. So this is great, right? This is both precise and easy to write. Questions on the first page. There's a lot here, right? Write the name of each polygon. It's a pentagon. Tell whether it is convex or concave. This one is convex because none of the lines, when we extend them, go inside, right? Mark congruent segments. Those 2 are congruent. We put tick marks there. That sounded like a bass guitar. I was sick at first. The second one wasn't as good. Use the distance formula to find the lengths of the sides of the polygon and write the perimeter. So, do we have to use distance formula? Not really if we're clever. We can use Pythagorean theorem, right? Pythagorean theorem is distance formula. I like them apples. Yeah? Look at the next page. How many sides? We call it a what? Very good. You're going to have some sides that are congruent here. Okay? They all look congruent. The sides are, but the angles aren't. Not that that matters. Look, a shape. Convex or concave, you think? Concave, it goes in, right? Oh, look. That thing. Oh, look. Good God. This line blended in really well. They are connected, by the way. Turn the page to the last page. We're on page 6, for those of you following along at home. Draw an example of a convex regular pentagon. So when we say regular, what do we mean by that? Okay, it's not what you're thinking. Regular means same sides, so all sides are the same. We call that equilateral. Remember, lateral means side, equa means equal. And it also has to be equiangular. So equal angles. Now, you don't have to draw it to scale, meaning you don't have to get out the old protractor and make sure all your angles are the same, right? Draw the shape and tell me by marking it that all the sides are the same and all the angles are the same, right? That's it. Number 7, can you ever have a concave triangle? If yes, draw one. If no, conjecture as to why. Self-development for 2 points. Remember, you need 10 by the end of the semester. Prove that a polygon cannot be both regular, remember it has to be equilateral and equiangular, and concave. My hint to you, what do you notice about the angle relationships as you go from a convex polygon to a concave polygon? Does the number of sides matter? Meaning that if you show a quadrilateral can't be both, does that also apply to any n-gon? So if you prove it for a quadrilateral, does that prove it for any polygon? I hope so, because if not, you have to prove it for each one. And there are infinitely many. Self-development's always optional. Enjoy the rest of your day.